Hello everyone. In this video, we will learn how to make the one-point perspective using AutoCAD. So this problem has been taken from the tutorial sheet number 8, and the statement you can read from the screen. So we need to make the one-point perspective of an object whose front view and top view are given like this, and the other data related to station point and the picture plane and horizon line and ground line is also given. So it is very important to read and understand this data carefully. So first we need to understand the geometrical information given in the form of orthographic views. We should try to understand how does the object look like from the given views. Then we should very clearly understand the location of the station point. Like in this case, it is given to be 150 millimeters below the picture plane and 60 millimeters towards the right side of the rightmost edge of the top view. Then regarding horizon line and ground line, that is eye level and feet level of the observer, these lines are given indirectly, that is with respect to the picture plane line. So it can be understood from this diagram that if when you are making the perspective view, if you draw the picture plane line here, then you need to draw the horizon line here, which is 30 millimeters below this, and you need to draw the ground line, that is GL, another 130 millimeters from the picture plane. So in this way, the eye level data, that is what is the gap between the feet level and the eye level, is indirectly given in this problem, that is 130 minus 30, 100 millimeters. This eye level data is indirectly given intentionally in this case. It is because that if you do the same problem by taking the eye level to be 100 millimeters, but you increase this value 30 to a very large value, let us say you take this value, if this 30 is not given to you, then you can take this value to be whatever, it makes no difference to the final result. But if you take this value too high, then maybe your perspective drawing that you make may not fit properly on your sheet. So that is why, just as an aid to the students, these dimensions of 30 and 130 are given in this problem. But anyway, from these two dimensions we can make out the eye level for the observer, that is 100 millimeters. So what are the steps that are required to be taken while we are making the one-point perspective view? The first step is that we will draw the picture plane line on the sheet. Then second step, we will draw the top view as given in the statement, and it is to be drawn in such a way that one face of the object in top view should touch the picture plane. Then we need to locate the station point as per the given data. In this case, it is 150 millimeters below picture plane and 60 millimeters on the right of the rightmost edge of the top view. Then according to the given data, we can also plot the ground line 130 millimeter below and horizon line 30 millimeter below the picture plane line. Then after making the ground line, we can draw the front view, which is also given in the statement. So we draw the front view while the object is resting on the ground line, and it has to be kept vertically aligned with the top view. And then we find the vanishing point, which lies on horizon line. Then we will connect all the vertices of the front view with the vanishing point, and finally we will find the piercing points for all such vertices of the object that do not lie on the picture plane while in top view. All such piercing points must lie on the picture plane, and in the last step we will draw the vertical lines from these piercing points on the corresponding edges to get the final perspective view. So now we will be implementing all these steps one by one in the AutoCAD environment. So let us go to AutoCAD now. So the given data is like this. This is the front view, this is the top view with the dimensions. Then from the given data, if we uh, look at it carefully, then we can easily make out that this data is actually, it represents an object which is something like this. So this is the isometric that we should try to perceive in our mind, that the front view and top view that is given to you will make an isometric like this. You need not make this isometric actually while you are solving this problem, but you should just try to understand the geometrical details. So this is the part of understanding the given geometrical information of the object. So the given data can be interpreted as an object in isometric like this, and just for the sake of understanding, let us name the different vertices like A, B, C, D, 1, 2, 3, 4 at the bottom. So we start with the first step. The first step is that we first draw the picture plane line. So I just let us make a picture plane line somewhere here, and then next is that next step is that we just make the given top view uh, and place the top view in such a way that one face, in this case the face that is AD41, which appears as a line here in the top view, so that face of the object is touching the picture plane. So we place the object in such a way that the face AD41 is completely touching the picture plane, right? So that is step number 2. And the step number 3 is that we locate the station point, which is given in the statement to be 150 millimeters from the picture plane, and it is 60 millimeters on the right of the rightmost edge. So the station point will be 150 millimeters down the picture plane line and 60 millimeters on this side. So if I just make one line which is 150 millimeters long, and then I take this line which is 60 millimeters long, then I get this point here as the station point. Then next is that after making the station point, we need to draw the horizon plane and the ground plane lines. So the ground plane line and horizon plane line, these are given with reference to the picture plane line. So the horizon line is drawn like this. This is 30 millimeters from the picture plane, and similarly we make this ground plane line which is 130 millimeters from the picture plane line. So you can see that this distance is 130 millimeters. So this distance is 130 millimeters, and from this data we can make out that the eye level is 100 millimeters from the ground line. So after making all these lines, the next step is that we need to draw the front view of the object as given in the statement. Now this front view has to be made in such a way that the object has to rest on the ground plane itself. So it means the front view has to be placed in such a way that it is resting on the GL, that is the ground line, and also the front view should be vertically aligned with the top view. So if I just draw a line just for checking it, if I draw a line from this place to this place, so the front and the top, these two views should be completely in vertical alignment. Now the next step is that we need to identify the vanishing point. Now to find the vanishing point, we just need to draw a vertical line from the station point up to the horizon line, because the vanishing point always lies on the horizon line. So this point here is the vanishing point. So vanishing point can be obtained by simply making a vertical line passing through station point and up to the horizon line. So this point here is the vanishing point. Now, after establishing the vanishing point, the next step is that we should connect all the vertices here in the front view with this vanishing point. So I connect, let us say 1 and A, and also connect similarly this point D here, and point 4 also you can join, although it will be a hidden line. Similarly, you can also join even this vertex here. So you can just join all the vertices in the front view to the vanishing point. Okay, for the time, just to avoid any confusion, I'm just deleting this, because this edge, like in the isometry, you can see the edge passing through 4 is going to be hidden 1. Similarly, the edge passing through this point is going to be hidden 1. So I'm just avoiding the hidden edges. So I can make this edge, this is visible, this is visible, this is visible, and this one is visible. So these 4 edges are drawn in the perspective, while all the visual rays from these points are heading towards the vanishing point. And you can also see that all these lines here in the perspective, they are non-parallel. They tend to converge at one point, which is the vanishing point, whereas the same edges in the perspective, they are parallel to each other. So that is the key difference between a perspective projection and an isometric projection. So in this case, just to add an element of realism, the edges, the vertices which are away from the observer, they seem to be smaller as compared to those edges or vertices which are closer to the observer. Now we have to look for all those vertices in the top view which do not lie on the picture plane. As already said in the beginning, that the object is so placed that this face, this yellow colored face, that is AD41, this completely touches the picture plane. So this line in the this line here, this line here, that is, this is face AD41. So this line is completely touching the picture plane. Now all those vertices which do not lie on this picture plane, that is vertex number named B, vertex named C, and also just below there is another vertex, that is 2. So this is actually not B, rather it is B as well as 2 beneath it, just below it. Similarly, this is not only C, but it is also C, comma 3. All these vertices, that is B, C, and 3 and 2, these vertices do not lie on the picture plane in the top view. So for all these such points, we have to find the piercing point. Now the process to find the piercing point is, let us say we are finding the piercing point for vertex B. So the process is that we go to the station point, that is here, and we connect that point, let us say point B, with the station point using this line. So I'm just changing the color of this line just to differentiate. So this is a magenta color line. So this line is drawn from the station point up to the vertex B. Now this point here on the picture plane, where this magenta color line touches the picture plane line, this point actually is the piercing point for vertex B. Similarly, we can draw another line for point C. So we connect C with this station point, and this becomes the so this point somewhere here is the piercing point for point C. Mind it, this since this line is connecting B as well as point 2 with the station point, so this piercing point is applicable for B as well as 2. Similarly, this line here is connecting point C as well as 3 with the station point, so the piercing point is applicable for vertex C as well as 3. So once we get the piercing point for vertex B, let us say, then from this piercing point we draw a vertical line. Now this vertical line should be ending at this line. Why this line? Because I am looking for point B in the perspective here. So logically I know that vertex B should lie on this line, and this line is coming from A. So in perspective, corresponding to this line AB, the corresponding edge is this one. So from A to the vanishing point. So point B must lie on this line only. Now where does point B lie? To find that, I just drop a vertical line from this location to this edge, which is A to VP. So I just end my line, my vertical line on this edge, and I can trim it also. So this point is now point B in perspective. So I can just name this point here. This is point B in the perspective. So this point here is point B in the perspective. This is somewhere here, just a second. So this point here is point number B, right? So I can just make a dark line here which represents the edge AB. So from A to B, this is the edge AB in perspective. Now I do the same thing for vertex 2 also. So I already have this piercing point for vertex number 2. I draw a vertical line. I just extend this line from here and let it come up to this location, and I can trim the rest of it. So this line is gone. I have point number 2 here. So this is vertex number 2 here, and I can darken this portion to indicate H12, and finally I can also connect it with point number B. So this is the face AB21, and you can also compare this with AB21 in the isometric. Right now, same process can be adopted for vertex C. So I just need to draw a vertical line from the piercing point of C, that is somewhere here. So it just comes here. I can trim the extra line. So that is point number C. So that's point number C, and I now just need to connect this C, D, and with B. So this becomes the top face ABCD. Now you can again compare, just for the sake of understanding, we can add some color to the top face, same color, let us say. So that becomes the top face here, right? So this is the top face ABCD, and you can also put the side ball color same as the one which is given in the perspective. So this is the side face, that is AB21. Now we are just left with one last edge, which is representing this small edge here. So this edge in the isometric also needs to be drawn in perspective. So we can just start from here, the corresponding vertex, and end here. So this edge in the perspective here is having its equivalent this edge here in the isometric has got its equivalent in perspective here. So we need to keep in mind that all the vertices in the front view, they need to have their visual rays rushing towards the vanishing point. And then for all those points which are not lying on the picture plane, we first find the piercing points and then drop the vertical lines to find those vertices on the corresponding edges in the perspective. So this is the process for making the perspective, 1 point perspective of a given object. Thank you very much. In case you have your queries, you can post those queries to us, and we will be able to handle your queries. Thank you very much.